Hi everyone. So today our problem is medium of two sorted arrays. Given two sorted array nums1 and nums2, return the medium of the two sorted array. And the hard point is the complexity would be log m plus n. So the most straightforward way is we combine these two arrays. The time complexity of the combined two arrays will be n big O of n plus n. So it does not satisfy the restriction of this time complexity. So what we should do, so here is the two arrays, and we know if we find the number, the time complexity would be log n, it must be the binary search. So in this case, it's the same. We apply the binary search algorithms to this problem. So how can we do that? The first array and the second array. Let's assume we combine these two arrays. So the total number will be 9 elements, and the first half of the array will be 5 elements or 4 elements. But in this problem, we choose 5 elements. I will explain why we choose 5, not 4 later. And right now we just stick to 5 elements. Okay, so the half will be 5 elements. And the first array, there are 4 elements. So the first half of the first array will be like this, 2 elements. So apparently there are 3 elements left. So in the second array, the first half will be 3 elements. So this is the partition. And so what is the medium? Because this is an odd number, there are 9 numbers. So let's say like 1, 2, 3, 4, 5. Like this is the array, let's assume. And the medium will be the middle number. So in this case, the medium will be either A2 or B3. So we just choose the bigger one. So it's a max of A2 and B3. So let's assume like number of the total array is like it's an even number. So let's say there's a A6, like A6. So the partition still look like this. So the first half will be 5 elements and the second half will be 5 elements. So you can see we don't need to change the partition. So in this case, what will be the medium? So if the number of the array is even numbers, so let's say like this, so the medium will be the middle 2 elements and divided by 2. So in our case, will be A2 and B3. We choose the bigger one, and plus A3 and B4. So we choose the smaller one and divide by 2. So this will be the medium. So okay, so yeah, so now we clear what it will be the result. So what is the correct partition? So the criteria will be A2 smaller or greater, smaller or equal to B4, right? And B3 will be smaller or equal to A3. So if we find this criteria, we know this is the correct partition and we can calculate the median. What if like B3 is greater than A3? So this means the A3 is too small. So we need to move our partition to the right. Yeah. So at this time, the first half of the first array is 3 numbers, and as a result, the first half of the second array will be 2 elements, like this. So this is the process of this, how we can solve this problem. So now we can like take a concrete example here. Left point and the right point will be, in this case, a little bit different from the normal binary search. So the left point, L, is 0, and right point will be the length of the first array. So which means the length of the first array is 4, so we use 4, okay? So in this case, the first partition M will be L plus 4 and divided by 2, so it will be 2, okay? So this means this is not the index, this is the first, the number of the elements in the first half of the first array. So number 2 means the first half is like this. There are 2 numbers in the first half, okay? So in as a result, M2, so which means the number in the first half of the second array is 5 plus 5 minus 2 is 3. So 3 elements like this. So this is the initial partition. Okay, so we can calculate right now. So 2 is smaller than 6, that's good. But like technically 4 should be like smaller than this number, but in our case 4 is greater than 3, so which means 3 is too small. So we need to move our middle point, the partition, to the right. So like L will be M1 plus 1, so it will be 3, and the right pointer stay the same. So M1 right now will be 3, so 3 plus 4 divided by 2 equal to 3, okay? So at this time, this is the new partition, and the M2 will be half 5 minus 3 will be 2, okay? So this is M2, okay? This is M1, this is M2. Okay, so in this case, 3 smaller than 4, good. And 4 smaller than 5, good. So we found the correct partition. So right now the median will be the greater number of among 3 and 4, so it's a 4. So median will be 4. That's the result. So let's take another example here. Like the first example here, the first initial partition will be L equal to 0, and R is the size of the first array, which is 4, and M1 is 2. Okay, so this is the first partition. M1 is here, and M2 is 3. So this is the second half. M2 is here. So 2 smaller than 6, that's good, but like 4 greater than 3, so we need to move the first partition to the right. Okay, so L is equal to M1 plus 1, so it will be 3, and R still the same, so M1 is 3 right now. So M1 is 3, and M2 is 5 minus M1, which is 2. So M2 is 2, okay? So in this case, 3 smaller than 4, that's good. But 4 still greater than 3, which means we still haven't found the correct partition. And we still need to move the first partition to the right. Okay, so L equal to M1 plus 1 is 4. And the right pointer is still 4, so M1 right now is 4. And M2 is 5 minus 4 is 1. Okay, so what if now? So it will be, the first array will be like this. So all of the number in the first array is on the left of the partition. So what is the left part of the partition? So what is the right part of the partition? We can say, in this case, the right part of the partition is positive infinite. And at this time, the second array will be looked at like this. So this is the second array. So what now? So the 3 is smaller than 4. That's good. And take a look at the second array. 3 is smaller than positive infinite. So that's good. So this is the correct partition. And the median will be the bigger number among 3 and 3, so which is 3. So 3 is the median. And similar, like if we, the first partition will be like this. All of the number is on the right of the partition. So the left part will be negative infinite will be. So this is the examples. So okay, so let's code up right now. So like to make it easy, we just assume the first array will be the length is smaller than the second array. So what if the length of the first array is greater than the second array, right? So in this case, we just simply swap the two arrays. So return self 2 and nums 1. That's it. Okay, so right now the length of the first array is smaller than the length of the second array. So the first step will be, let's calculate the total half of the two arrays. The total half will be nums 1 plus nums 2 plus 1 divided by 2. Why plus 1? It is because, like, if you look at this, so if we plus 1, the total half of the two arrays is the same, like for the even number and the odd number. Like say, take the example here. There are 9 numbers of the two arrays. So the first half will be 4, will be 5, and the second half will be 4. And if there are 10 numbers in the two arrays, so the first half will be 5, and the second half will 5 as well. So we just plus 1, and the L is 0, and the right point is and length of the first half, and the length of the first array. Okay, so that's it. Okay, so right now we do the binary search. So M1 is equal to L plus 1, and M2 is the first half minus M1. So at this point, we have to notice that M1 is the length of the first half, not the index, the length of the first half of first array, num1, nums 1. And M2 is the length of the first half of nums 2. Okay, so we are like looking for the partition, like nums 1, M1 minus 1. So this is the number just left the M1 is smaller than nums 2, M2, and nums 2, M2 minus 1 smaller or equal. Yeah, they're equal to nums1 and 1. So this is the partition we are looking for. Okay. Okay. So like we use left max 1. This is this number. So this number, if m1 is greater than 0. So what if m1 is equal to 0, which means on the left partition there's nothing. So we just use negative infinite. And the right is min, should be minimum of the partition will be m1. If m1 is smaller than the length of the partition. So remember, the right pointer initially we use the length. So if the right pointer is the length of the array, which means there's nothing on the right of this partition. So in this case, so if m1 is equal to the length, so it will be a positive infinite. Yeah. So for the second array, it's pretty much the same. Okay, so now we can calculate. So if like left max 1 is smaller than right min 2 and left max 2 smaller or smaller equal, yeah, smaller equal right min 1, then we find the solution. And there are two possibilities. So one is the number of the total array is odd. So in this case, we just so look at this. So if the number of the total array is odd, we just take the greater element among 3 and 4, right? So it will be max left max 1 and left max 2. This is the answer. If nums1 plus nums2 modulo 2 equal to 1. This is odd number. Else, if it's even number, so we just take the greater number among the left part and the smaller number of the right part and divide by 2. So we just use a greater, we just copy paste here, greater and the smaller number of the right part and divide by 2. So this is the answer. And so what if the left max is greater than the right min? This means, so if this number is greater than this number, so which means this number is too big. So r is equal to m1 minus 1. Else L, which means the number, like if this number is greater than this number, which means this number is too small, move to the right. So m1 plus 1. Yeah. So that's the solution. So let's run it. Yeah. Okay. So I will upload the Java and the JavaScript solutions to my Git repo and put it in the descriptions. And if you like, please follow, and it will help me to grow. And so in the end, I will explain why we use partition. We use the number, not use the index. So it is because it's like easy to code. Let's assume, like for example here, so the total number will be 9 and the half. So if we, in this way, the half will be 4. 9 divided by 2, it will be 4. So the first half will be 2, okay? The left point is 0 and the right point is like the normal binary search. It will be 3, the index of the last element of the first array, and the middle point will be 1. So this is the partition. And so what if the second partition? The second partition will be 4. So if you eyeball it, the second partition will be 4 elements, right? 4 elements like this. But how can we calculate? It will be the half, 4, minus what? Minus 1. Minus 1 will be 3. So 3 will be 0, 2, 1, 3. It will be here. So it's not correct. So we have to like plus 1, right? This is a 2. Okay, so which means this is 2. And the second half, so M2 will be what? 2? No, because the first half is, the M1 is the index, so the second half, like to be consistent, it should be index as well. So it need to be M2 need to be 1 as well. So it's 2 minus 1. So as you can see, there are like multiple conversions. So this is like increase the complexity of the code, and it's easy to have bugs. So I will suggest, like for this specific problem, we just use the M would be the number of the first half. That is easy to code. Okay. Yeah. Thank you for watching, and please follow.